Hello, everyone, and welcome to our webinar, Pivot, Twist and Turn, How to Build a Crypto-Agile Security Organization. We have Nick France, CTO of SSL, and Tim Callan, Chief Experience Officer here at Zectiga with us. And not only will they talk about what crypto agility is and what typical challenges businesses face, they will also talk about how to get an organization crypto agile. As always, we're recording this presentation and we'll share it with you after the webinar. And if you've got any questions during the presentation, we'd love to hear them. Please pop them into the chat function and we'll answer as many as we can at the end. Nick, Tim, over to you.
Thank you so much, Leah. Good to do this again with you, Nick. You know, I always enjoy these things.
Same for me, Tim, and good afternoon, everybody.
And so let's start with a basic definition of crypto agility, right? We talked about crypto agility. Crypto agility is a modern concept. It wasn't really around in the early days of the internet or early days of computers where people thought you could establish some cryptography and have it be very static. But one of the things that we've learned over the years, over the decades really, and that is becoming more and more urgent and important as time goes on, is that there is a need for our cryptography to be able to change, right? And go ahead.
No, I was going to say you're right. We have to adapt to things changing a lot more rapidly than they used to. When you mentioned, back in the day, it's not something we imagined. It's a more modern term.
Well, and my favorite example of this is RSA, right? RSA was created in 1978, I think it was. And here we are, right? Still using it. And, that just isn't going to happen moving forward. Like, there's no way you can imagine that we're going to create a cryptographic standard and it's still going to be in operation in 40 years. Just not a thing. And so instead, and why, right? Why? So we just rattled off. These are some of the things that happen that occur, right? We know that as we've discussed, shortening certificate lifespans are a very real thing. 90-day TLS is definitely in our future. Other examples of shortening of certificate lifespans do occur. Cryptographic algorithms just become no longer safe, right? We had to deprecate SHA-1 because it was determined by, smart cryptographers around the world that this is just something we could break. There are examples of zero-day vulnerabilities, things like the Heartbleed problem or the Debian flaw that basically mean that suddenly you might have to change out your keys in an awful hurry up to including today. Sometimes there are massive revocation events that are required. So a great example of that was when it was determined that there was too little entropy in millions and millions of Leaf certs, Leaf SSL certificates. They all had to be revoked. And then obviously quantum computers. Quantum computers are going to force all our cryptography to change. We're going to move on to that. But all of these things are part of the new normal, right? They're part of the life, the fabric and the foundation of what computing and digital systems look like for us now. And when an IT professional going into the working world in 1990 might have said, I'm going to establish one set of cryptography and use that for the next 10 years, that is just not the world that we live in today.
No. The pace of change, the constant security threats, the threats of the unknown. I mean, the quantum threat that we'll talk about, Tim, it's right. Something we don't know. Is it going to happen tomorrow or is it going to be 10 years? We simply don't know. And the pace of change of computers get faster, better algorithms come out, older ones are broken. You mentioned SHA-1. We've had to increase RSA key sizes time and time again. Even though it's a veteran algorithm, as you've mentioned, it's still something we need to keep changing. And because of the hugely increased volumes of things like certificates and keys, not just certificates, keys, and other cryptographic assets, because the volume of those that enterprises have to manage is so big, it's not simply a case of, oh, there's a new standard, I'll change these 5 keys I've got and I'll do it once a year. It simply isn't scalable. So we've got to talk about getting your enterprise to the point where it's agile and it can adapt to these changes, both things we know about with deadlines and things we might not know about that will just come up on us suddenly.
Right. So let's drill down on a few of these things, right? So the 90-day certificates story is very important. And for anybody who isn't aware of it, on March 3rd in 2023, so Google maintains this public-facing website, microsite, if you will, which they call Moving Forward Together. And what Moving Forward Together is it's the way that the Chromium project can telegraph what it intends to do in the world of public certificates and roots. And the Moving Forward Together page is, I think, a best practice. It's great because obviously anything that Chrome does is incredibly important to the whole web ecosystem. And by conveying their intentions and ideas ahead of time, Chromium has a chance to get feedback. They have a chance to vet their ideas with the community at large. And ultimately, even if this is something that winds up happening, it gives all of us some warning, and we can think about what we need to do, and we can adjust. And so on March 3rd, Chromium in their Moving Forward Together page announced two things that are very material and significant. And you're actually the person who called my attention to this, Nick. The first one was that they were going to reduce the duration of a permissible SSL certificate to 90 days. Right now it's 398 days. So that is a pretty massive reduction in time. And then connected to that, they intend to reduce the DVC, the domain validation, domain control validation time period, reuse time period for data, also to 90 days. So that, the idea here is that every 90 days, certs are being re-upped and those certs are being domain control validated, so that all of that stuff is very current. This is going to be extremely important, don't you think?
Yeah, I mean, we've talked about this a lot, you and I, Tim. Obviously, it's a hot topic, and people are very interested in how they're going to adapt. And it's one part of this idea of crypto agility. But as you said, the lifetimes are coming down. It's the not just the certificate lifetime, the domain verification lifetime. And I think, as we'll talk about, the thing to mention is 90 days is just this stated goal, right? Google have been very clear. We've really appreciated the clarity they've given us, but 90 days isn't the end goal. So again. Right. The idea that this might be something you can do or just do manually. Oh, they're going to change to 90 days. I'll just pay somebody to do it manually several times a year. That's not going to work. That's not going to make you agile, and that's not going to get to where you need to be.
Yeah, I agree with what you're saying. I mean, if part of your point is that 90 days is the next step, but not the last step, and we can't imagine that 10 years from now it's going to be 90 days. Of course, I agree. It's going to be much shorter than that, right? And this is the next step in that journey, but that journey isn't done probably until they're being renewed every day. I mean, right? Like that's probably
there's going to be a low end
bound
on this, but we don't know what that is. There's going to be a practical low end bound. I mean, I reckon it's probably going to be somewhere between 3 and 10 days. As an educated guess, but it's certainly not going to be 90, and it's certainly not going to be the 1 year and a bit that it is today.
Yeah. But nonetheless, bringing it back home a little bit, the immediate problem we're going to have to work on is this worried about, instead of doing things, once a year, now you're doing them maybe 5 times a year, right? Or 6 times a year. And that becomes next thing. So in fact, what does it mean? So this is an important point. I hear this a lot. People say, oh, well, if certificates are going from 1 year to 90 days, that means I'm going to have 4 times as many certificates, right? Is that right, Nick?
It's not 4 times, no.
Right, because 3 times 90 is 360. How many days in a year? 365 to 366, depending on the year. And that means that you literally would have outages if you only did them once a quarter. So once a quarter is not a realistic cadence, right? A realistic cadence, I think, is probably 6 times a year. You do it every 2 months.
Yep. And that's more realistic. That's what people are likely to do. Renew in advance, make sure these things are working rather than wait until the last minute.
Right. So suddenly my work just got 6 times as hard as it was. And likewise, DCV also has to be performed more than, and maybe you don't do that all 6 times, I don't know, but more than 4 times a year as well. And so that winds up all of this winds up being, a very big deal. The when question at the bottom here, Not in 2024.
No, I think we
Yeah.
can agree that's not going to happen next year now. But in terms of an overall strategy for agility and even just adapting to this one thing that, as I say, Tim, you and I have talked about a lot as a singular specific topic, we just because we don't have a date on it doesn't mean people should sit back and go, oh, hey, well, maybe I don't need to worry about this. Maybe I shouldn't think about it. Partly because we know it's going to happen and we know it takes time. Partly for all the other reasons we're going to talk about that you need to be able to prepare for.
Right. I think that's a very good point, Nick. If I need to build a truly certificate agile situation, and if that's going to require 15 months to get done, then it's distinctly possible that something like this could be coming in Q1 to Q2 of 2025. So if it really is going to take me 15 months to get done, then I better get started. If I get started now,
Absolutely.
I'm fine, right? But if I don't get started now, I'm not. So that's part of the reason we're talking about this ahead of time. Like literally, I talk to plenty of enterprises. They look at something like this at this level of complexity and they say, gee, you need to give me more than a year to do that. Say, okay, fine. Right now you have more than a year. If you go do it, you're okay. If you sit around until someone lets you know that these things are coming along in 6 months or 3 months, then you don't have more than a year anymore. And so this is the time to do your plans, figure out what you have, inventory your certificates, understand where they're coming from, prioritize them, understand risk, look at what systems you can update and what you can't, what you can automate deployment for and what you can't. What do you need to do to update those so you can automate deployment? This is the time to be doing that work. And if you do that work now, then when the certificates come, you'll be able to deal. So this isn't just bad. So the other thing that happens is I get a lot of people, the people who are on the front line to deal with this get upset about this, but shorter certificates are actually good for the ecosystem. And you're a big proponent of this idea, Nick. So why is that?
Yeah, well, I think the slide answered it pretty well. Is that the shorter something is out there for if we find something wrong with it, if we find it's bad, whether it's compromised, whether it contains invalid or incorrect information, the shorter amount of time that thing is out there is better. I think that's a fairly common sense statement to make. I think everybody should accept that.
Yeah,
I mean,
it just reduces the risk window, pure and simple.
It reduces it. If we take certificates that we could issue a long time ago, back in the day for you and I, we were issuing 10, 15-year certificates. If there was something wrong with that, you could wait a maximum of 10 or 15 years for that certificate to expire out and to no longer be functional. And that's an awful long amount of time for something bad to be out there, especially something when we're talking about security, which is what we do. And so it's not a good idea. And the shorter the time things that are bad are out there, the better. And I agree with you, Tim. People are a bit up in arms about some of this, saying it's going to cause problems. But I think they have to understand that there are very real threats here. There are very real reasons why Google are driving this. And they're not the only trust program, as you and I know. I mean, Apple have potentially hinted towards doing this. I'm sure Mozilla and Microsoft are thinking about it because they understand the very real risks to the internet and the internet users at large when these things go wrong and when bad things are left out there for too long.
And there have been real examples of this. Like I remember one of the big ones is when the world decided we needed to deprecate SHA-1. We mentioned SHA-1 earlier in this webinar. When the world decided we needed to deprecate SHA-1, there was a deadline was given, and after that deadline, you couldn't issue certs with SHA-1 anymore, and that deadline rolled around. And this was back in the era of 3-year certs. So all of a sudden, we hit that, and now we're in a post-SHA-1 world. And yet SHA-1 world certificates are sitting there in production more than 3 years later.
Yep.
And this is the thing where this was the real wake-up call for browsers to say, no way, this is not okay, no way, right? And that was one of the big drivers to say, look, we really need to get certificate lifespans considerably shorter. And that's still going on for the reasons you said. All right, so it's not just things like Heartbleed and just generally, better computers being faster and knocking things out. There's actually a real major event horizon coming, which is the popular availability of quantum computers. So quantum computers at this point are real things. They really work. There are plenty of development efforts going on around the world. There's not really a question about whether or not you can make a quantum computer. At this point, it's just an engineering problem of figuring out how to make quantum computers bigger and bigger. And the basic how it works is a quantum computer is not 1-0 gated like a traditional computer. It takes advantage of quantum physics, which means that instead of bits, they have what they call quantum bits or qubits. And a qubit can be a 1 and a 0 at the same time. And if you say, huh? Then welcome to quantum physics, because that's what everybody says about quantum physics, but that's the way it works. And due to some of the specifics of quantum physics and math and stuff that I do not have the degrees to understand, it turns out that there are certain types of mathematical problems that get insanely easier with a quantum computer.
Yep.
And
well, it's important to remember that you mentioned RSA, Tim, being around since the 70s or perhaps even earlier. RSA being one of the fundamental algorithms that our modern encryption is mostly based on, and there's a couple of others. There's different types of algorithm, but they're all fundamentally based on difficult mathematical problems, difficult for current computers to do. And the point of the quantum computing is that because it's so fundamentally different, it can do the things a normal computer takes, till the heat death of the universe to do. If it was trying every single combination, quantum computers can do in infinitesimally smaller amounts of time.
Yeah, and I actually have a chart. I have a chart, right? So look at some of these things, right? And Shor's algorithm is the key. Anything that's subject to Shor's algorithm is the one that really could be broken. So if we look at some of these things, this came from NIST about 4 years ago, this chart. And what the key here is you can kind of think of them as apples to apples. So an ECC of 256 is about equivalent of an RSA of 1024. And where these things today are considered to be unbreakable, look at the time for a quantum computer that they're now going to say like done in 3.5 hours for an RSA 1024, 28 hours in a 2048. So the amount of reduction is absolutely dramatic, as opposed to if we look at algorithms where you get something like an AAS or a SHA-256, right? You got 2.61 times 10 to the 12 years to get AES 128, as opposed to 3.5 hours to get RSA 1024. So the degree to which these tasks are decreased in time is 10 or 15 orders of magnitude. It's just amazing. And it's so big that you can't solve it just by making the keys longer, right? If you got some hack that cuts the key space down in half, add another bit, and now you're even again, right? But you've got so much reduction in the key space here that the keys would have to be so big that they would be completely unworkable and practical in the real world. So
I mean, if you look at this table, Tim, as well, the RSA, 4K RSA, 1496-bit RSA is about the top of what's commonly used today. I mean, most RSA for certificates at least is at 2K. But if you look, the difference between 28 hours and 228 hours, that's not for an attacker, for a nation state, for someone that's determined. Barely a couple of weeks is not a whole long amount of time.
Yeah.
And the other thing to bear in mind is these attacks as well, when they get to this capability, we're not just talking about breaking the stuff that's happening, we're also talking about breaking stuff that attackers may have stored or may have on disk. It's not just things like certificates, it's stored encrypted information. And if they can cut through these things so quickly, it's going to be a big problem.
That's such a great point, Nick, right? The basic concept, the idea of what we call harvest and decrypt, right? Or steal now, open later, right? That if I happen to get inside of your network and I own your network and I capture the blobs that I'm pretty sure are the really valuable stuff, even if I can't open it today, what I do is I store it and I document it really well with metadata. And then I know someday I'll have access to a quantum computer, and when I do, I'll go open it then.
Yep.
And for some secrets, that's perfectly fine. Doesn't matter for my credit card number, right? My credit card will be expired by the time that rolls around. But if we're talking about your secret industrial process that is the foundation stone of your entire business, that it took you 20 years to develop and you expect to use for the next 50, then sure, fine. They'll wait a couple years until they can get a quantum computer. They don't really care.
Yep.
And so that's a real problem. And by that argument, really it's already too late today. But it is what it is, right? So what we need to do is we need to get new cryptography in place as soon as we can. So all of these things are going to be drivers, right? As the new post-quantum crypto primitives come out, as the certificate spans get shorter, as we just need to update our cryptography because of the world and computing power and, clever people coming up with, clever attacks. All of what that does is that forces us toward this concept of crypto agility. So let's talk about how to get crypto agility. A big one at this stage is knowing what you have. We talk about people with this a lot. If you don't have if you don't know what your cryptography is, or if you don't know what your certificates are, then you can't update them. You can't change them, right? If there's a basic idea behind crypto agility is that I want to be able to swap out my certs anytime I want at any time, right? And I need to know these are my certs and they need to be swapped out. If you don't know what your certs are, you can't swap them out. So
Exactly.
This is where we come to this idea of discovery, right? Take an inventory, understand what your cryptography is, understand what your certificates are, since they gate and govern most of this cryptography that you use, and know what your plan is to swap this stuff out if you have to change it out.
Yeah, I mean, we see discovery being a fairly sizable problem, right? So, I mean, you and I have all dealt with customers and enterprises where they simply don't know what they have, and what tends to happen is one certificate slips through the gaps and causes chaos. We've all seen, the articles that make the news. I think there was even one this week where a problem with a certificate or a problem with a key causes huge impact, whether it's an expired certificate or a key that gets leaked. And it's those ones that you don't know about that cause the most problems. Maybe a certificate that's been purchased by a contractor for a particular project they were working on a couple of years ago. It's lapsed. The email from the provider went to a dead email box. You didn't know about it. And all of a sudden, big parts of your production system have come down because you didn't know about it. Now, I've seen people do this kind of management in something as simple as an Excel spreadsheet. I definitely don't recommend that. But at least you have an idea of what your portfolio looks like. But you really need to get a handle on your discovery of what you've got. And there's many different ways to do it. We might not talk in complete depth about all the different ways to do it, but there's certainly tools that are available to scan networks inside and outside of your enterprise, find out what certificates and keys that you have there. And then there's also tools where you can look at things like the certificate transparency logs for your public certificates, see what's issued to your domain names and your organizations, and just get a catalog on it and make sure that there's not anything you're missing, so that when you need to make changes, you're able to do it for everything, but also that nothing's slipping through the cracks that's likely to bite you later.
Yeah, I think that's exactly right. And then, that's great. You got to know what you have, but if you do have to change things out quickly, doing that manually is difficult. It's error prone. It's slow. It's often incomplete. And so another thing that we strongly advise people about is look at your automation options for deployment. And in particular, let's talk about Acme here, right?
Yes.
Acme is the most commonly supported protocol, API that you can use. There's a very good chance that you're using at least a lot of the server operating systems that you're using in an environment probably support Acme. And if you can automate certificate deployment through Acme, that has all those benefits I said before. It's just much faster. It doesn't require a huge amount of human capital. Stuff doesn't get forgotten, and stuff doesn't get done wrong.
Exactly. I mean, automation is pretty much a cornerstone of IT now, right? People aren't really building new machines by hand. You aren't building servers by hand. You aren't deploying your applications, hopefully, too much by hand. So automation makes sure that you can repeatedly do it, you can do it correctly, you can do it without human intervention, and all the other benefits we could speak about. But specifically for certificates, you're absolutely right, Tim. Acme is effectively the gold standard. But if we look at what we talked about before, the volume of certificates is massively increasing. The volume of keys you have to keep a handle on is massively increasing. And there's no way you can handle that manually. There's no way you can go from a growing number of annual certificates to then a growing number of certificates you have to replace 6 times a year. You're simply not going to be able to do that without some kind of automation. And the other things we've talked about, the quantum apocalypse, the heartbleed is definitely a big one, because that almost predates things like Acme, is that if suddenly something happens tomorrow whereby all CAs have to tell all of their customers to replace big percentages or all of their certificates in let's say a 5-day period on the outside,
exactly.
People aren't going to be able to. You can't do that without automation, and those things can happen, and they probably will happen in the next few years. And so it's important to get some automation deployed.
And unforeseen problems occur. So like one of the things that was interesting was during the 2020 government shutdown, I was watching, and some other people and I were watching a variety of U.S. federal government services, and we would just watch them go offline. It's like one day you couldn't log into a certain system and do a certain thing anymore, and these things were just failing because the government was shut down for more than a month. And during that period of time, people weren't going to work, and they weren't going to work and doing the things they weren't doing. And part of what they weren't doing is they weren't maintaining systems, including deploying certificates. And so if you've got a system that also is ultimately depending on a certain individual does a certain thing, what if that individual gets a terrible case of COVID, right? And you see something extreme like a government shutdown where they send everybody home and stuff just breaks, it stops working. And you look back and you go, well, if someone had built an automated system, then the automated system would keep right on running and you wouldn't see all of that stuff fail.
Absolutely.
And that's a better way. That's a better way to do it. Now, if you take all of these concepts to their logical extreme, you get certificate lifecycle management, right? Certificate lifecycle management is the idea of an integrated, bespoke platform that's been built on purpose to do your certificate work for you. And CLM is a very, I'd say, strongly growing platform technology for a reason. Because it has all of the benefits that you and I talked about before, and it gives you much more robustness in your systems. Your chance of a certificate-based outage goes down considerably. You have visibility on what's going on. It's predictable. It's reportable. All of that comes when you start looking at a robust CLM, and that's a real important thing if you want to be able to know that you can swap out your certificates whenever you need to do.
Yeah, I mean, my extreme example before, Tim, of an Excel spreadsheet, sadly, is not that extreme, but this is what it should be replaced with, right? This is what you really need to discover what you have, to be able to do the automation on it, to be able to get a handle on your portfolio, to get certificates from different places, whether it's internal or external. And it's just the name that we give to the tools to do all of these things that we're talking about, right? That's ultimately what it is. CLM is a collection of all of these tools: discovery, automation, management, general lifecycle management for certificates and keys. It's just all that brought together under a single application.
Yeah. And then the other thing that you can think about when you're doing this is how this fits into your other platforms. And so it says vendor consolidation at the top. That's certainly one opportunity for that. You can get your CLM from somebody who's providing other services for you, like your digital certificates by way of example. We all know the arguments in favor of vendor consolidation, but another thing to think about in the same breath is integrations, right? So, there's a lot of people who they have a CLM, but they really want to run a lot of their IT operations somewhere else. So they're interested in how their SIM or their ServiceNow or some other aspect of their operation can drive certificates or can suck in information from certificates and use that. They're interested in alerting. Maybe this is PagerDuty, maybe this is Slack, maybe this is Teams. So understanding how you can have something like a CLM that fits into your broader fabric of
Yep.
IT management platforms is also an important part of making sure that your certificates are always there, are always current, are always visible, and are always what you want.
It fits in well with what we talked about automation as well, Tim, because automation is not, I mean, we talk about it specifically for crypto and for certificates, but it's obviously wider applied to IT. People are not deploying services, by hand with configuration scripts anymore. You're using things like Terraform and Ansible and Puppet and Chef and all of these tools for orchestration or infrastructure as a service, and integrating the CLM into that means that you can, deploy this service, this database server, this application, and go get a certificate from here, know that it's going to get the right certificate, know that it's going to be managed, know that it's going to renew in time, and know that you can click a button or run a script and have them all changed, which is the fundamental tenet of crypto agility.
Right. And when you start to mention these DevOps environments, if you want to talk about short certificate lifespans, right? Now we're talking hours.
Yeah. Yeah.
So,
which is good, because that shows that it is possible. It absolutely is possible. I mean, certainly a public certificate and a private certificate, fundamentally the same, do have some differences, particularly in things like validation, but that doesn't mean that you can't do large scale, large volume automations of short lifetime certificates today. It's entirely possible already, and hopefully people are going to adopt it more and more.
Yeah. So, and I think we already hit that stuff on this slide. We just kind of got ahead of that. So, that's kind of our short introduction into, why crypto agility is important, why it matters to your organization, and what you should be thinking about when you try to present a crypto agility environment for your enterprise moving forward. This is a topic that certainly I talk about a lot. I have a podcast called Root Causes, a PKI and Security podcast that I do with another friends of Nick and mine, Jason Sirocco, and we have new episodes every week, and we talk about all kinds of topics involving PKI, encryption, digital identity, CLM, things along those lines. We'd love to have you join us. Just search for Root Causes PKI podcast, or go to wherever you listen to podcasts and search for Root Causes. We'll be right up at the top. We'll probably be the first result you get. Look for that logo. That's us, and we'd love to have you come join us on a regular basis. And with that, I think we're ready for questions. Leah, do we have any questions?
We've got a few today, yes.
Okay.
First one, how about just-in-time certificate issuance and validation?
How about just-in-time certificate?
Yeah.
Go ahead.
I mean, I think we touched on that, Tim, when you talked about, the things like Kubernetes and things like those orchestration tools as well, because that's fundamentally what it's doing, right? So just in time means getting the whole certificate issuance process and verification process done very, very quickly, which, as we've said, is entirely possible. So it does happen today. It is entirely possible to automate public certificates, so publicly trusted, what we call SSL certificates, complete end-to-end, from requesting them, verifying the domain control, getting the certificate issued, getting it installed, and having that entire process take a matter of seconds and literally be done just in time. So it is entirely possible today. We can certainly do it. I think most CAs and most vendors can absolutely do that. The technology exists. Certainly that question maybe being asked a few years ago. And in terms of things like EV and OV validated certificates, it's entirely possible there as well. So it does already exist. It is possible, and I'd encourage, if you want specifics and how that works for you, just contact either your account manager or reach out to us or our sales department, and we'll absolutely get you all the details on how you can get there.
Cool.
Right. The next question is, if you had to give some top recommendations on how to become crypto agile, what would they be?
Oh, I think we hit some of them. Again, automation, incredibly important. Acme really is your path forward there. It's not your only option, but it's your best option. And that's something. Like, if you're gonna work on a couple things, really work on, how do I make Acme really work? And there's a point I was gonna make, but then we got off it, which is that when it comes to Acme, don't fall into the mistake, the trap of thinking that you need to have absolute 100% coverage to benefit from the protocol. Because what's going to happen for a lot of people is they're going to find that lots and lots of their environment and their certificates can use Acme, but then there's some stuff here and there that cannot. It's a different system. It's a legacy system. I got it through M&A, variety of reasons why this might happen. And if you can automate 90% of your certificates and you only have to deal with the other 10%, do that.
Absolutely.
Now, still try to figure out how to get rid of those 10%, but don't let those prevent the 90%, right? And this is a mistake I see a lot. People go, well, here's the problem. We don't have Acme everywhere. Fine. Do you have Acme most places? Yes. Great. Do it.
Yep.
Do it now. Do it first.
I agree, Tim. I think my recommendation would be two things. I think I completely agree with you on Acme. I think that should be the focus. So go and see where Acme fits into your organization. Go and see what supports it today. Go and see what doesn't support it today. And like Tim said, will it never support it? Maybe that's a longer term. Is it something you need to push your vendor on and say, hey, can you do Acme support? Go do that. So focus on Acme. The other thing I'd say is a little bit into that discovery portion. You don't need to build out a complex discovery system. You don't need to be necessarily doing scans of all your domains and IP addresses every day, but certainly see if you can get one scan done, at least get one set of discovery done to find out what you have today. It gives you a starting point. Is there anything you're missing? Are there some surprises in there? Do you have more certs than you thought, less certs than you thought? But do that exercise to get an idea of what your kind of certificate estate looks like. And then absolutely, I think, focus on Acme. And those would be my two recommendations today.
Cool.
Okay, great. I think this question kind of ties in with it a little bit. What happens for legacy systems where certificates can't be automated?
I think Tim's absolutely right there. And I've said it the same to other partners and everybody else, the customers, don't let perfect be the enemy of good. Don't aim for 100% because I don't think many people will get there, at least not straight away. If there's this small percentage of legacy systems that maybe can't be automated today, maybe never can be automated, if you can get everything else done and you can take that load away and not worry about it, have the majority of your infrastructure be automated and be reliable, then you can focus more on the legacy systems, that smaller, that 1% of things. Now, there may be some where you simply can't do any automation. There may be some ancient mainframe that just simply doesn't have a way to support it, or some ancient air gap system or something. I don't know. There are going to be these systems out there. There may not be anything you can do. You may have to handle that manually. You may have to look at whether it needs certificates for certain things, whether it needs certificates for the specific types of certificates, and if there's something else you can do. Or, as I mentioned earlier, maybe it's something that you need to apply pressure to vendors on. It may be a legacy system, but if it's something that's still important to you, there may be some investment you have to do to figure out how you can automate it. Because if you need to use public certificates or any certificate on there, really, then you are going to face this problem. And as much as automating the rest of your infrastructure gives you time to focus, it's still something you're going to need to solve in the end.
So Nick, I agree with all that. The one thing I want to add to this legacy systems point is that there is a game changer here, which is post-quantum crypto. And if you've got a legacy system that you can't automate, what's the likelihood that that's also a system that you can't update to post-quantum cryptography?
Very good point. Very good point.
If you are stuck with RSA and ECC in a world where RSA and ECC are fundamentally breakable, now is the time when we need to ask ourselves some hard questions about whether these legacy systems just plain have to go. And I appreciate there's a reason this is hard. If it was easy, we already would have done it. This tends to be old stuff. It tends to be very foundational stuff. Other things are built on it and around it. They're critical systems we can't get rid of. That's why it's there. It was what the first IT team put in place back in the 1980s, and somebody wrote it in COBOL. I get that. But if you've got fundamental foundational systems that are completely breakable by a quantum computer, and you're imagining a world where any sufficiently resourced actor can bring a quantum computer into the equation, then we need to say, look, I know we've always said we can't, but if the alternative is that our most critical systems are compromised and our most essential information is stolen, maybe can't turns out to be we really can. It's just kind of painful.
Yep.
And under those, or very painful. But I think when you start to think about post-quantum crypto, we have to think a little differently around this idea of just leaving legacy systems running and hoping there isn't a problem.
Yep. I mean, I think that it's an incredibly interesting point you bring up, Tim. And I think it's gonna precipitate a lot of very tough decisions and tough discussions because you're right. I mean, the things I think of when I mention things like mainframes, I'm imagining banks and telcos and financial institutions, which are the kind of places where these legacy systems exist. But as you point out,
And those
these
are the
kind
places
of
where the stakes are high. Yes.
Exactly. Yeah.
Yes.
That's where the information is that nobody wants to be still taken or stolen. So there's certainly going to be some tough decisions to make in terms of those legacy systems. But I think Tim makes the best point, which is if you can't do any level of automation with it, how are you going to be able to handle the real future and the real dangers that lie ahead? And you maybe have to make some difficult decisions about what to do with it.
Yeah.
Okay, great. And then we've got the opposite question, really. Can I implement post-quantum cryptography myself rather than waiting for my vendors?
Kind of no. I mean, if you thought you were going to go back to assembler language and create an entire environment for yourself from scratch, then you bet you could. But none of us is really going to do that. The problem is that everything we have is built on all of these fundamentally interoperable systems, right? I need to be able to go out and buy a piece of hardware, a piece of software, a service, and have a great degree of confidence that I can plug it into 10,000 other things that I might buy and they all are going to work. And that's the real world we're really in. And so where we stand now on the cryptographic standards is NIST has released a series of new standards. There's a key encryption module, right, a KEM, and there's a signing algorithm, which is crystals Kyber and crystals dilithium, respectively. And these are going to be the foundational algorithms that we use moving forward. And these are going to be, they're going to have to be built in, right? So you're going to need software that supports it. Your operating system is going to need to support it. That browser that connects to you is going to need to support it, or that other server that connects in from who knows where is going to need to support it. Then you're going to need to be able to get certificates that support it. I can't even give you one of those today because they're not defined, right? The specifications are not yet defined. And so those need to be defined first before we can even issue them or before we can even create a private CA that can issue them. Yep. And so all of that work does need to be done. You really can't, you can dink around, you can get the algorithms, you can throw them in sandbox environments, you can do some stuff like that today. You can do that. Get a sense for how they work. You can read the specs and understand what they're going to mean in terms of things like key lengths getting bigger. You can do work like that. But you can't really be implementing this stuff today unless you are an extremely well-resourced technical organization.
I agree with that. I think it's great for something to look at, and people have asked this similar question to me before, and I'm sure you, Tim, is can I get ahead of this? I think the difficulty I would see with it is not just all the points you've mentioned, but with the standards still evolving, although NIST have set those in, they've set those out now. As you say, there's a lot of other parts of the stack and a lot of other moving pieces. There's what will a browser support? What will things like OpenSSL support? What will embedded software support? What will devices support? And until that's all ready, what you could end up doing as a worst case is kind of building out and testing for something that then isn't what actually happens to materialize as a standard in the future. So you could risk spending a lot of effort on something that isn't going to be used, or you could end up, spending a lot of effort on something that then you can't even practically test because the rest of the stack you deal with isn't there. Right. So I think it's definitely something to be aware of. It's definitely something to look into from a very high level. But I think that plays into everything we've been talking about with agility. Yeah. It's better to be prepared to be able to make a change to a post-quantum certificate than it is to worry about what that certificate looks like today.
Exactly, and that's why I moved back to this slide. You can do the stuff on this slide. That's the stuff to do now. Inventory your crypto, know where it is. Have an automation plan. Implement automation where you can, right? have a plan for swapping it out. That's the work that you can do now. And that work will help you so that when the time comes and you have hardware and software that supports it, and you can get a certificate that enables it, that all you have to do is push the button.
Exactly.
You can be ready to push the button when the time comes.
Agreed.
Right, then we've got another question around timings. I think the concern is if a certificate was issued today, would it be valid for a full year, or would the 90 days come in between and reduce that?
Yeah,
length
no,
of a certificate?
thank you. We can clarify that. Perfectly clear. The way they always do with these kind of rules, and I'm sure would be done in this case, would be that existing certificates that were issued prior to the rules change would be allowed to run for their full term. And short of some kind of massive security failure, that is how the norms on these rules always work. And I can't imagine it being different in this case. So, there will be some day, we'll call it T0, where the new certs you get can only be 90 days in length. If you get a cert at T-1, it would still be the existing time period. You'd be able to get it for up to 398 days and get a 1-year cert. And that means there would be a period of time where these old 1-year certs would be there in the market until they termed out. And that would be fine, right? But the new certs you get you'd only be able to get a cert for 90 days. You'd have to run those, at a much more frequent cadence.
Yeah, exactly that. We've seen this with all these standards changes that have happened over the few years. Is existing certificates don't really get infected, right? And like you said, Tim, unless there's specific security-related concerns, things are misissued or things are compromised, then it's what you just said. It's around that date. Something before that date is fine. Something after. One important point to remember is reissues. Okay, so reissue is generating a new certificate for the same details, or often as part of the same purchase or order with the CA.
Mm-hmm.
If you reissue a certificate, you're essentially creating a brand new certificate.
Yeah.
And so the rules will apply when that is created. If I have a 1-year certificate today, the rules change tomorrow, and I reissue on Saturday, it's going to have to abide to the new rules, even though I may have purchased it in the past. So that's something to bear in mind as well.
Yeah.
Right. Next question is, what are the financial implications of changing certificates more regularly?
So let me tell you what I think this question is asking, because I got this a lot. We were out at RSA talking about this when it was all very fresh. And people would come up and they would say, okay, so let me get this straight. Now you're going to make me buy 4 times as many certificates. And there was an implication in there that they were going to spend 4 times as much money on certificates. And obviously this is a future thing. It hasn't happened yet. And therefore you don't see any public CAs actually rolling out any new pricing and packaging. But I don't believe that's what's going to occur. I think what's going to occur is the CAs are going to recognize that you're going to get a certain amount of value per year, and you're going to need to make the fundamental business model match that. So hypothetically, if you're now moving from a cadence of 1 certificate a year to 6 certificates a year, maybe your price is 1/6 of what it was, right? Or something in that ballpark. Or I think maybe what's more likely is you start to see CAs offering something where you buy a year's worth of coverage, and then within that coverage, you change your cert out as often as you want, right? You got a maximum of 90 days, but if you want to do it every 60 days, great, fine. It's okay if you want to do it every 30 days. I don't really care. You bought a year's worth of certificate coverage, and I'm just going to let you cycle them out when you cycle them out. And that kind of thing feels to me like a much more modern business model, and something that fits better with the way we do computing today anyway. So, I very much predict that you'll see all of the major public CAs and the public CAs that you use introducing models that aren't fundamentally exploitive and that make you whole on the value that you would have gotten anyway.
I agree with all that, Tim. I think what I certainly would like to say, and I think what we're trying to say, is that we don't quite know yet what these models are going to look like, right? Obviously, internally, we've had some discussions, but no, because this change hasn't happened yet, the CAs haven't come out and fundamentally changed the way they do business. But the intention is not going to be, certainly from us and probably from any other CA, to fundamentally change the financial cost of these certificates. It's not going to go hugely up. It's not going to go hugely down. It's going to obviously remain the same because that's what people understand. That's what people budget for. And you don't really want to make any drastic changes to that because that will have bigger negative impacts. So yeah, I think what you said, Tim, is absolutely right.
Cool.
Great. And then we've got one final question, and I think it summarizes everything quite nicely. Can you speak on automating DV certificates? How is that accomplished?
Well, DV certificates are pretty much the easiest to automate and the best kind of, the best type of certificate to automate there. And they can absolutely be automated, and certainly we issue them in their tens of thousands an hour in a fully automated fashion. Acme is once again the key here. Acme is very much designed for that use case. You can have an Acme client, or if you have a CLM solution, you can use maybe a software agent there, or you can use the APIs. But fundamentally, you're talking about a series of steps. You generate your key of whatever size you want. You are going to generate a certificate request. You are going to then prove control over the names, the domain names in that request, and that can all be automated as well. So you might want to have a hook into your DNS provider, or you might need to be able to place a file on your web server. These are all standard ways of verifying a domain. Then we will check that. We will confirm that your domain is controlled by you and is verified. We will then sign the certificate and provide that back to you. And quite honestly, I think kind of an industry standard here is that whole process for a DV certificate could be done end to end, assuming you have everything in place with those parts about the domain registrar. The entire process can be automated end to end in sort of a sub 5 second kind of time. We're not talking more than seconds here to have that whole process run out. And then when you receive the certificate back, your client, your Acme client, or another piece of software will then go ahead and do the installation and any other specific to you steps, like what you need to do. Do I need to restart things? Do I need to put this in other bits of my infrastructure? But the actual automation of a DV certificate is actually fairly straightforward, and as I say, can be run end to end in only a handful of seconds.
Great. Well, that was all the questions. Thank you everyone for your time, and thanks Nick and Tim. If you've got any more questions, do get in touch with the Sectigo team directly, and we've got one more webinar coming up this year about the 5 pillars of certificate lifecycle management. We'd love to see you there, and the sign up details are on our website. And thank you for watching today.